How many different types of functions are there? Let's explore this together. Hi, and welcome to Algebra Examples. This is Dr. Finch. I have a PhD in math and over 20 years of experience in math education. If you have questions that you'd like to answered, please send me an email at purplefinchmath@gmail.com. All right, let's get into it for the day. We're going to look at different types of functions, and we're going to focus mainly on the functions that you will be seeing in a college algebra or possibly even a high school algebra class. So the first type of function that you are likely to see, and let's change that, is going to be a constant function. These are the easiest types of functions. They're very cute and nice. If we look at the way that they are constructed, let's just get ourselves a little XY axis here. Our functions are going to look like y is equal to c, where c is a number. And it's a constant number, which means it doesn't change. So for example, if we had y is equal to 2, our function would look like this. We have our graph, y is equal to 2 would be right there. And notice our function is just a straight line. It's a horizontal line. Our constant functions are always horizontal. And there's really not much to them. So let's bump it up a notch. All right, the next one that you are likely to see in an algebra course will be linear functions. These ones you will be spending a lot of your time working with. Linear functions have that form that a lot of us are familiar with. We see them before an algebra class sometimes. Right? When you're lower level math, you kind of start getting into it. Y is equal to m times x plus b, where m is the slope of our function or how steep that line is. And b is the y-intercept. So this is a number where the line crosses the x or the y-axis. Just as a recall. So let's look at an example. If we get our little graph up. All right. We'll do a function like this. There. Y is equal to x plus 1. So if we have a function like y is equal to x plus 1, we notice that the y-intercept is going to be 1. So it's going to cross our y-axis where y is equal to 1. Let me put in the x and y here. And our slope is 1, so it has a steady increase. It's not going to be too steep, but it's not, small either. All right, so linear functions you spend a lot of time with. The next one that you spend a good amount of time with would be quadratic functions. But we're going to actually talk about these slightly different when we talk about types of functions. So instead, we're going to group them in a different way. We're going to first talk about functions called power functions. And a power function in the quadratic form is going to look like y is equal to x squared. Notice I didn't add anything beyond the x squared. It's just an x squared. You might also see y is equal to x cubed, y is equal to x to the fourth, and so on and so forth. The more generalized power function is y is equal to x to the n, where n is an integer. And I'm also going to say n is non-zero just to make it nice. In this case, you know, it actually, and well, we can actually say let's have n be bigger than 1 too, because y is equal to x is a linear function. N is bigger than 1. There we go. All right, so our power functions are the more basic ones that we're looking at when we look at things that get a little bit bigger. And I'm going to actually draw two different graphs here. So here's y, here's x, here's our axes. Our power function y is equal to x squared is going to look like this. In fact, any of the even functioned power functions are going to have this shape. And what I mean by this face shape is that they are basically a smiley face. So always looking up. The odd power functions, I'll do this one in a different color, are always going to have a slightly different look. I put up the one for y is equal to x cubed. Odd power functions have that shape. And so our power functions look something like that. If you have a negative sign in front of it that flips it, and there's little bits here and there, but in general, your power functions are always either going to be a smiley face or this elongated, slightly different looking shape here, where it's just going up and to the side. Okay, so that's the simplest form where you're going to see your quadratic that you're used to looking at. Let's look at the more complicated quadratics, and we have a different term for these types of functions. So these types of functions we call polynomial functions. And there's a lot of them. So for our quadratic ones, and I'm just going to give myself a lot of space here. They have that full-on form that we're used to seeing, ax squared plus bx plus c. The slightly bigger ones would be the cubic functions, where our first term has an x to the third power. And we can keep on going. I could write up, if you want to see the generalized form, just let me know, put it in the comment. I'll type it up for you, but you don't need to know it. Usually for an algebra class, the only ones that you're going to see is the quadratic and possibly a cubic function. It's not likely you're going to see much bigger than that, if at all. So those things are kind of nice. And of course, as you can imagine, the bigger power functions, this exponent here just keeps on getting bigger, and we've got a longer and longer string of items after that. So they can get as large as we want them to be. All right, next up, I'm going to do another type of function that you're not likely to see as often in an algebra course, but you will be seeing if you take a trig course, and that would be the circle functions. These are the functions that have the form y squared plus x squared is equal to r squared. And in this case, where r is called the radius, it's the radius of a circle, r is a real number. Right. And so in this case, let's see if we draw up our little graph. Ooh, there we go. Our circle, let's see if I can actually get a circle on here. Oh, there we go. We have our nice little pink circle here. It's a little bit out of focus, but that's okay. We'll call this y squared plus x squared is equal to, let's just say it has a radius of 1. And I'll put a 1 there and a 1 there. So it's always going to hit at 1 on all the points here on our axes, and it's a very nice picture. All right, the last one that I want to show that we'll look at again, you are not likely to see this in an algebra course, but if you go on, you will see trig functions, especially if you're going into calculus eventually, if that's where you're planning to land. Trig functions are essential. They're super important if you're going to be an engineer, if you're going to work with like bridges, stuff like that. You want to know how some of this works. Let's go through, actually, there are two that I want to show you. The first one is our sine of x function. And these ones have a lovely shape to them. So here's 2 pi, here's pi. Sine of x always starts at 0 at the origin of our graph, and it keeps on going on a rotational basis, and it has an evolution of 2 pi. If you keep on, you can go backwards, and it goes in the both sides infinitely long, both directions. Super nice. The other one will be cosine of x. And when we look at cosine of x, let me make that a little bit longer. There we go. Cosine of x is basically the same shape. The only difference is cosine of x is going to start at 1, and it's going to have the same repetitive nature to it. And this goes on, and it goes on both directions as well. And I'll say the boundaries are 1 and -1 on both of them. So there's your traditional trig functions that you need to work with. Tangent you will work with as well, but you don't often have to draw that or worry about drawing it. Tangent inverse is more interesting in my opinion for a calc course. I always throw it in a Calc 1 or Calc 2 stuff. But those are the basics to know. Thank you for listening. Again, share a comment if you want to look at more specific functions.